My dear students, today I am going to explain about overview of microprocessor, table of content about microprocessor, generations of microprocessor, architecture of 8085 microprocessor. A microprocessor is an important part of a computer without which you will not able to perform anything on your computer. It is a programmable device that takes in input, performs some arithmetic and logical operations over it, and produces the desired output. In simple words, a microprocessor is a digital device on a chip that can fetch instructions from memory, decode, execute them, and give results. Next, generations of microprocessor. First generation. The Intel Corporation first introduced the microprocessor in the year 1971, naming it as 4004. This initial microprocessor could perform basic arithmetic and logical functions. It also contains a control unit capable of fetching, decoding, and execution. Second generation. The Intel Corporation first introduced the 8-bit processor in the year 1973 with the name Intel 8008. This was followed by an enhanced model, the Intel 8088. Third generation. The third generation introduced microprocessor capable of performing 16-bit operation, introduced in the year 1978. This generation was represented by processors like the Intel 8008, Zlog Z800, and 80286. Fourth generation. The most used and famous 32-bit microprocessor was Intel 80386. Fifth generation. Since 1995, microprocessor with 64-bit processors which fits 64-bit process like Intel Pentium, which allows multi CPUs in one. Now, coming to architecture of 8085. 8005 is an 8-bit microprocessor designed by the Intel company in the year 1977. It has the following configurations. It has 8-bit data bus, 16-bit address bus, 16-bit program counter, 16-bit stack pointer, 8 6-bit registers arranged in pair BC, DE, HL. It requires plus 5 volts power supply. Functional units of 8085. Accumulator. It is an 8-bit register used to perform arithmetic, logical, I/O, load, store operations. It is connected to internal database and ALU. Next one, ALU. ALU stands for Arithmetic and Logical Operations. As the name suggests, it performs arithmetic and logical operations like addition, subtraction, and or etc. General purpose registers GPR. There are six general purpose registers in 8085 processor, that is B, C, D, E, H, L. Each register can hold 8 bit of data. These registers can work in pair to hold 16 bit of data, and their pairing combinations is like BC, DE, and HL. Next, program counter. 8005 has 16-bit program counter used to store memory locations of next instruction to be executed. The microprocessor increments the program whenever an instruction is being executed so that the processor of program counter points to the memory address of the next instrument that is going to be executed. Stack pointer. It is also a 16-bit register, works like stack, which always increment or decrement by 2 during push and pop operations. Next, temporary registers. It is an 8-bit register which holds the temporary data of arithmetic operations. There are two types of temporary register. One is temporary data register and another are W and Z registers. Next, flag registers. 8005 has an 8-bit register having 5 flip-flops which can hold either 0 or 1 depending upon the result in the accumulator. There are 5 set of flip-flops: sign flag, zero flag, auxiliary carry flag, parity flag, and carry flag. Next one, instruction decoder. It decodes the information present in the instruction register. Timing and control unit. It provides timing and control signals to the microprocessor perform operations. The following timing and control signals are which controls external internal circuits. Control signals: ready, read bar, write bar. ALE comes under control signals. S0 comma S1 comma IO slash memory or comes under status signals. DMA signals: hold and HLDA, nothing but Hold acknowledgement. These signals comes under DMA signals. Reset in and reset out are two signals to reset the outside the processor and processor itself. Next one, interrupt control. As the name suggests, it controls the interrupts during a process. When a microprocessor is executing a main program and whenever an interrupt occurs, the microprocessor shifts the control from main program to processor. After the request is completed, the control goes back to the main program. Like main program is performing, while performing the main program, there is an subprogram is nothing but the interrupt. There are 5 interrupt signals in 8085 microprocessor, that is INTR interrupt, comma RST 7.5, RST 6.5, RST 5.5 and trap. These are the interrupt control signals. Serial input and serial output control. It controls the serial data communication by using these instructions. They are SID and SOD, serial input data and serial output data. And last one is address and data bus. Data bus carries the information to be stored. It is a bidirectional, whereas an address bus carries the location to where it should be stored and it is unidirection. So, data bus is bidirectional and address bus is unidirectional. It is used to transfer the data and address IO devices. Architecture of 8085. So here we are having some registers BC, DE, HL. Next, ALU unit to perform arithmetic and logical operations. Accumulator. Next, temporary register. Interrupt controller. Serial IO signals. Address and data buses to transfer the data from outside the processor and to transfer to outside the processor to receive and transmit the data is nothing but a bus. This is the overview of 8085 microprocessor architecture. Thank you.